Anytime you're ready.
All right. Hi, my name is Meredith, and I'm with Kristen and Ray, and we are forecasting demand for a large alcoholic beverage distribution company in the United States. So we use time series models and deep learning models to forecast the demand for a couple products for this company. We then compared these models to a naive model. We found that for the 5 of the 6 products we looked at, the time series models outperformed the naive models and reduced error anywhere from 2.5% to 67%. We also found that for one product, our deep learning CNN model outperformed the time series model and reduced error by 3 to 10% more. So forecasting demand is an important business problem for any company in any industry. So our goal was to provide models to our company that would allow them to forecast demand for their products more accurately. This would provide them with important business insight into inventory and supply chain management. Our approach was unique because using deep learning models to forecast demand has not been used before in the alcoholic beverage distribution industry. Next slide. So we focused our research on 2 popular vodka products. We call them Product 1 and Product 2. And here you can see we have graphed the demand over time for these 2 products, separated out into the different customers. So we have customer A, B, and C. These customers are liquor store chains that get their stock from our company. And as you can see, each of the customers have very different buying patterns, which is why we decided to model for each product customer combination. So we had 6 in total.
So the models we use a naive model, which is a copy value of previous year, time series, and deep learning. As we can see on the right is the neural architecture we used. In addition to stacked LSTM, we use a hybrid model that combines the advantage of LSTM's capacity to capture the long-term dependencies and the CNN's capacity for efficient feature extractions. At the bottom, here are forecasts of 2 different types of models. We can see models all have their own behaviors. And here is a comparison for the best for 6 months horizon models for both products of our 3 chains. Each bar represents the mean absolute error, or MAE, for the best model of each model type. As smaller the bar is, means lower the error is. So therefore a better fit for the model. MAE is a metric we use because it does not penalize large errors as much as other metrics, such as mean squared error. Also, it has the same unit as the value we try to predict, so it's easier to interpret. We can see from the plot that performances vary for every product. 5 out of 6 products showed improvement with at least one of our models. In addition, for the majority of models, for the majority of the products, time series and deep learning have similar performance. In particular, our model performed very well on product 1, chain C, as it decreased error by 52% and 42% by time series and deep learning, respectively.
We got values for that graph by aggregating our results from tables like these, which show more detail for the product and customer combinations and all of the models that we tried for each product. So here we have one of these products which has pretty stable behavior over time. And in our table, the green highlights the best MAE that we found for each of the 6, 12, and 23-month horizons. So for this data, we found that a signal plus noise model had the best results across all these horizons, which is one of our classical time series types of models. And here we have sales from another product and retailer, which has a couple of very large outliers. And for this data, we found that our hybrid CNN model achieved the best MAE across all the horizons and reduced the error 3 to 10% more than the next best time series model. Now for one of our products, the behavior was extremely seasonal. And so unfortunately, we could not outperform the naive model in any of the horizons. And we were disappointed with this, but the CNN model was pretty close behind, and future work could definitely try out different models to try to beat out the naive approach for this product. So we were glad that we could beat out the naive model 83% of the time. And more specifically for stable or seasonal data, our traditional time series models were best and could reduce the error up to 67%, while for data with high variance or outliers, our hybrid CNN model was best and could cut the error nearly in half. And finally, in the case of extremely seasonal data, the naive model actually performed best for our alcoholic beverage distribution company. Thank you.